All right, so all right, well, the product of a 2 by 2 and a 2 by 2 is a 2 by 2, so the zero matrix that's being referenced here should be a 2 by 2 matrix containing all zeros. It is a question of what values we want to enter in the unknown matrix B. I'll just call it very creatively A, B, C, D. So we go through the process of multiplying and see what we come up with. So first row by first column. So remember, we're essentially dotting the first row with the first column. So it's 1A plus 2C equals 0. All right, first row, first column. First row, first matrix, first column, second matrix. But still, first row, first column, which puts you in the first row, first column of your resulting product matrix. All right. It's another possibility. Negative 2A minus 4C equals 0. All right, second row, first column. Now, first row, second column, B plus 2D equals 0. Then the last entry would be second row, second column. All right, easy enough to do it algebraically, I guess, but we're not really interested in that. Do a quick 2R1 plus R2. All right. So in doing that, we end up with kind of an interesting development. We end up with A plus, well, and we could have probably recognized this because the second equation is a scalar multiple of the first equation, so it's probably going to boil out that way. But we end up with a zero row. Right? So this tells us that really it's just the relation that A plus 2C equals 0. Right, and so you could do the same thing with the other one, but it's got the same coefficients. Right, so you could actually just kind of jump right down to the idea that, I'll draw the arrow. B plus 2D equals 0. Not always the case, but it happens in this case. All right, so what do we do? Okay, what do we do? I don't remember. I mean, I don't want to just plug numbers in. I mean, you could just solve, but So we just need a relation. Okay. I just remember this being more complicated. I think, all right, well, it looks like A has to be -2 times whatever we choose for C, where C is a free variable, and B has to be -2 times D, where D is a free variable. I just thought it was more interesting. All right, well, anyway, let C equal, use two different non-zero columns for B. So let's let C equal 1 and B, D equal 2, I guess. If that's the case, then A is equal to -2 and B is equal to -4. So this is my matrix B. Well, construct A 2 by 2 matrix B, so I guess that makes sense. But I guess we should do a quick checkarooski here. Oh, I'll just cover that up for the time being. Quit. Okay. So you get the 0 matrix. Right, okay. Yeah, okay, so I think I was thinking of a different problem. This wasn't as interesting as I thought it was going to be. All right, well, anyway, these two vectors are, one is a multiple of the other, so they actually fall on the same line. So whatever matrix we come up with, the two columns need to have that relationship where one is a multiple of the other. They need to also fall on the same line. The idea here is that when we're talking about the matrix multiplication, it's a form of the dot product. So if you just identify basically just the first row, first column, if we dot those together, we should end up with the 0 vector, because the dot product of two perpendicular, well, we want the 0 vector, so we want two vectors that are perpendicular to one another, right? So that explains why this relationship boils down the way it does, because if I just look at these as ordered pairs, x, y, find the slope of this, x, y, find the slope of that, you'll see that they're negative reciprocals to one another, all right? So, but answers vary, which would make this just an awful problem for a test. I mean, from your perspective, I'm sure it's great.